We're literally taking paper and turning it into an advanced technology. It's paper electronics. So I think that's pretty revolutionary in itself. Our vision is to really reduce unnecessary e-waste. I think there's so many electronic components that people don't get to see. They're often unseen. And so I think what we're trying to do is to bring awareness to the unseen electronics and to also push advanced technology further by making it simpler and more sustainable for the planet. We were all just fascinated about wanting to design for nature and with nature in mind, so not human-centered design and problem solving. So we were thinking about, okay, what can we do to kind of advance technology, but still building it for a better planet? And just through a lot of brainstorming, iteration, research, we kind of slowly narrowed down the focus, and we came up with using this laser technology to create paper-based, fully recyclable RFID tags.
RFID stands for radio frequency identification. And so it's basically a smart kind of like electronic circuit. You can almost think of it as a smarter version of a barcode.
Yeah, so oftentimes like an RFID tag is made up of a metal antenna, microchip, layers of adhesives, and they're sandwiched into clothing price tags, for example.
And for something that only gets scanned just a few times, and then after the life cycle of the product as well, it very much contributes to e-waste. We just think that's a lot of resources and energy that goes into a very simple product.
Everyone wants to track and trace products.
And we are able to achieve that by replacing all the metal components in a conventional RFID tag with a carbon-based alternative. And the way we create our carbon-based antennas is by taking a bespoke paper substrate and then using very specific laser settings to turn the existing carbon content of those wood fibers into a more conductive material. So that way we're almost kind of directly laser engraving or electronic circuitry onto paper. And what that means is now the only two inputs are really the substrate material and the energy consumed by the laser. So the main difference when it comes to our RFID tags is that they are fully paper recyclable. So overall, the carbon dioxide footprint of the product is much lower as well. We estimate it to be around 60% lower than conventional RFID tags.
What we're trying to do with our pilots is to see how far we can push the technology. So looking at different industries, retail, packaging, for example, in the healthcare space, I think, tracking medicine, tracking patient movement. There's a lot of work around how do we create the best tag for all of those different spaces.
From a technological perspective, the kind of support that we're looking for right now is really just being able to get our hands on as many different materials as we can. Typically, these are bio-based materials, and just see if our technology would be compatible.
I think from the commercial perspective, we know that the RFID tag business is really a volumes game. So we really need to kind of work with partners to kind of scale up faster. So something we see that could really help us do that is by licensing the technology. So imagine if we could integrate the laser heads directly into the production line of, say, a converter that makes labels. We can create the RFID tags right at the source of manufacturing.
It's just the overall environmental impact of a smart piece of technology that we really want to become bigger, and we want it to be more accessible, and we want it to be available to more people.
So there's a lot that can happen with our tags, and I think the sustainability element is critical.